org2b, orange class, unit 8. We're looking at the final standard. But before doing that, I just want to mark some of these guys and give them names. Some of them I had to look up the official name of them and the formulas. So let's see what we got here. Anybody know this first guy, what type of function he is? Linear. It's a line, so it's a linear function. So that guy will just write in. They didn't put that much space. If you're a big writer, it might be a little tricky. We'll just go ahead and put in linear. The linear function. The parent function, the original that will produce any line you see automatically begins with either, I'll put a y here, y equals f of x, or I'm sorry, y equals x, or f of x equals x. I won't be doing the y on all of them, but what's true is on every single one of them, the f of x is another way of saying the function that has a letter x in it equals whatever. Somebody different, and then we'll check in. This second guy, anybody remember the name of this guy? Parabola. Now, the way they're going to name that, let me see, yeah. The picture is a parabola. I'll put that on there, but they're going to call it quadratic function parabola, so I can spell it right. Parabola. And then we have here quadratic. So anytime you see a U or a rainbow, you know for sure that quadratic is the official name of it. The picture, they'll often call it a parabola. Anybody know the equation that goes with the original one that gets you a U? Filthy, right? The third one in line has been part of the polynomial functions. We know it could be a single, or double, or triple if it goes through that line that way. Anybody know what the equation might be called for that one? Or what we're going to write down here? This one, yeah. Yeah. So it is going to be x to the third power. And when you raise up to the third power, you usually say a certain word. What do you say? Instead of x to the third, you'll say, and for that reason, this guy is actually called a cubic function. We're just getting these guys in so that because they've shown up again and again, and Unit 8 is all about one final review, even though we're using decimals mainly to produce the pictures, but the intense version, paragraph, and they do all other kind of stuff. Just want you to see the basic version. You can do what I'm about to do with a highlighter initially. You can do it kind of with your pencil. If you have a pen, don't do it with a pen. But this guy here, you can put like a soft line through him. If you have a soft line, if you have a highlighter, you can put a highlight through him. We haven't used this guy, and so as a result, I won't name him. His friend over here, I think we've seen him before in the first semester. Anybody know the name? I think it's so much like another one that we're going to use. I don't want to take him out. There's a difference between him and this guy down here. Anybody know the name of this guy? I don't know. We would have seen him maybe in Unit 5 last semester. In any case, I'm going to put him in. He is a square root function. Should I include him? You know what? I don't know. I'll include him. Square root function. And hopefully you'll see the difference between him. You'll see the difference between him and this guy down here. Hopefully when I move this up, all the words go with it. I'm nervous about it already. We'll see if it will make that move with it. This guy, this ramp going up. I didn't recognize what type of function that is.
Isn't that the one with the lines?
Not this one, no, it's going to be down there. This guy is going to be an exponential function. He's the guy who's just going up faster. Exponential. This guy you would have seen probably in Unit 4. Is connected with logarithms, kind of the opposite of logarithms. Like it's a line shooting up. Logarithms, the line starts down and kind of goes up as well. So let's see, how do I write that one? Exponential. What is the equation that goes with that one? This should be the ABX. Where are you? No way. I'm going to write this one two ways. The way they chose to write it was interesting. They chose to write it as 2 raised to the x power, but it's not always going to be a 2, so I'm going to write the general one. So I'm going to write the one below it. A, B, X. We did this one on one of the problems before, and there may be another one that shows up like this for this unit. So what are we doing right now? Right now we're just naming functions that you will have seen, which is what Unit 8 is all about. Revisiting some old functions. So let's see. Will you go up, or will all the words just stay where they are? Our survey says. Dang it. All right. Well.
I felt like I was
Alright, I'm erasing these. Hopefully you got them. If you didn't, hopefully look on to Neighbor, rewatch the video. Alright. So let's see here. This guy right here, he's showing up today. Anybody know the name of him? He looks like the other guy, but the difference is he starts down low with the line is next door to what is called a vertical asymptote. Anybody know what an asymptote is?
That's when it approaches a line, but it never exits.
Right. So this graph is approaching this line if you're going to the left, but it never touches it. It's just like it's a boundary. It's a line you don't cross over. You can get as close as you want to, but you don't cross over that. It's an asymptote. This one happens to be a logarithmic function, and we're going to mess around with this today. So let's see, do they write the entire word? They do logarithm function. Log. Rhythm, where do I put that H? It comes after the I. Just like now, put H-I. Nope.
I think it's I-T.
They spelled it, yeah. Yeah, but they put it that way. I'll write it the way they put it. If you want to put it, if you want to switch it around, do something with it, you can. Logarithm.
Okay, that's
Let me take a look. They didn't put one. So if you need to rewrite it with Pirate's Field, right view, you can do that. Otherwise, write this guy, just put post on it. Right. So maybe the idea is in math, they spell different. Here's the log x. This one is what's coming today. All right, here it comes. Don't say it out loud. I want you to put a letter. Don't say it out loud. I want to see if you can guess right. One of these guys, don't do it in pencil because you'll need it to erase maybe if you get it wrong. One of these guys is a cosine and one of them is a sine. Your job is to look at the original picture very closely to see if you can decide. My hint to you is going to be at the 0 marker, that is at the y-axis. Do you start down on the ground? Or do you start up in the air? That's supposed to be the thing that kind of tells you, am I looking at sine or cosine? Write it down. And then from there, we will decide together which is which. And from there, we decide which is which. We'll be able to know. All right, here it comes. The one in the middle. Someone who has an answer first, and then we'll take them back up. Sine and cosine, the one in the middle.
I think that this is the cosine.
This one right here in the middle, we're going to use this one first.
Never mind. I don't.
Do you sing it out loud?
I give up.
Going with sine.
I think that one's sine and the other one's cosine.
The guy in the middle is in fact going to be sine. How can we tell? Because I wish there was a way to make a connection. Sine starts on the ground, but mass and sine doesn't go with ground. Starts on the ground. Snake. Yeah, but they both are kind of slithering. Hopefully one day it hits me. Hopefully one day it hits you. But this guy is sine because he starts on the ground and he goes up. Let me see what they call this guy though. Do they call him a sine or do they? Yeah, no, they go straight sine. Actually put in the words, so sine function. And this one is just written as sine. Are they going to put an X?
You just said
Are they going to put an X? They put an X.
showing your hair.
Alright, write it down, sine X. And of course now you can switch to the other guy. Making cosine With the highlighter, though, please, with the highlighter, start that sine up from the ground, and then for the cosine, with the highlighter, start that cosine up in the air so you can know that makes the difference between them. Where it starts, because again, if you shift the one, they're going to land on top of each other. But it's where they start that tells you. Cosine, I got no kind of a thing. Alright, you got 0 sine, cosine. I have no little thing to say. Cosine x, cosine x. Write it down, write it down. Even if you just came in, just try and catch up. You probably have to write off a neighbor.
Jacob sent me a picture of his dad.
Alright. This guy down here, Sammy had mentioned it earlier, is from another unit. I kind of wanted to cross a line through it to make it, like we're not covering it, but we have seen this one way back in like unit 3. When we were moving the gravel around, we moved some. So this one, we moved this one. He is an absolute value. Is that how they wrote it? Yeah, he's an absolute value function. Absolute value. Absolute value function. And like Sam was trying to say, those 2 bars, which is kind of interesting how they would choose that. Those 2 bars mean anything you take out of it for all the work inside, you want the positive version of it. Okay. This guy here, he's a step function, but we're not going to mark him again. If you have a pencil or a highlighter, just go through with it on that one. Just to say that we haven't seen it before. But if you heard it, what do they call it here? They call it
the ladder.
They call it a greatest integer function. Greatest integer function. Step function is what it's also called sometimes. And this is the kind of thing that says this. You are a freshman anywhere from 0 to 59 units. The minute you hit 60, you just bump up. You don't like gradually go up. You bump up to the next level. And then from 60 to 119, to 119 units here at school, you are a sophomore, 10th grader. The minute you hit 120, you bump up. And so you kind of step up to the next level without something in between. And those are how step functions work. Kind of with cell phone plans, you know, you get to use them to, well, in the past, you have to use it for X number of minutes. And after that, your price changes. Well, nowadays, of course, everything is free. Yeah, I don't know who does that anymore. Do me a favor, this guy here, you put a line through him. Yeah. He had a name, his name was Logistic Function. Logistic Function, but we'll leave him alone. And you know what, let me do this. Let me actually put down the formula for the ones we crossed out. So this one here, the step guy, where is the guy? INT. You can write down, just so you will see it. Who knows, one day might show up again, you're like, oh, wait a second, I've seen that before. Where's this logistic, where are you? He's weird. He's way math. 1 over 1 plus e to the negative x. That's a weird equation. Yeah, that is a little wacky. Anybody know what number e represents?
Energy.
Like, pi represents a number, e represents a number.
Oh, it's 2.6. It's something like that.
The 2 point is right, 2.718. So whenever you see the letter E, it actually represents a number. Just like pi is always 3.14. Why they choose not to write 3.14 or 2.718, I don't know. All right, did we get them all? There was one that I feel like I didn't write.
Oh, I go back to elementary school.
It's approximate.
For the record, you won't be able to turn in this sheet as one of your 6. It's just information I wanted to get to you. And now we are ready for the grand finale. Easy then hard. Computers, please turn those on. Oh no, I wasn't even recording any of that.
Thomas. You had one job.
I say she's trying to encourage me. She's doing tough love. Alright, here it comes. You guys work on that second one while I restate some information for the first one. All right. For this first equation up here, the degree is going to be a 5 because you add the exponents. There's a 2, there's a 3 when it's in factored form. The orientation is positive. As I think Roz said, there's no negative sign up front. The solutions are always the same as the degree. So that same 5 here tells us the solution. The roots, how do you get the roots? Check the parentheses, the same number opposite sign. Check the parentheses, same number opposite sign. Are those roots a single, a double, or a triple? You just check the exponent. The root 3 is going to be a double. And a double just means that it's going to look like the letter U, as in a parabola. When you look at the root 2, it's going to be a triple. How can you tell? Just check the exponent. And what does that mean? When you look at the picture, it's going to look like an S, or it's going to bend when it goes through. I'm going to come around now to check mark. I can't believe next time. Check and see. Yes. There's a page we did just a moment ago. If you need to back up, let's see if I can get to it. Half of the sheet is filled out for you. The other half, you should have come to class. List the names and the functions. All right, come around the check mark. All right, we're going to put these into decimals for those who aren't here. Let's see. Oh, did I say what page this was? What page is this one? I think it's page 19. Page 19. I should have said the other page was a handout, the one with all the different functions. They don't have to be at the same time, so as long as you can sketch them both in. Let's see if I can get this out. For now, Anna, put that away, please. All right, let's see if I can get that in. Decimals, let's see if you're working today. I think some people's already did. That first one was a y equals, was that parenthesis? Is it x plus 1, the first one? X plus 3? And the second one, oh, because I didn't hit the shift button.
Oh, I'm sorry. I apologize. Oh,
How was that second guy?
X minus 2.
X minus 2, Q.
Q.
Let's close that. Alright, there's the picture on mine. You should be able to make it a little bit thicker.
Look, it actually curves like instead of
So take a look again, based on what you have. Alright, I see some pictures. So again, now that you've done these in life, in the last year you've done it by hand, we had to try to sketch it. Now they're like, hey, let them use technology, and then go ahead and sketch those in as best you can. For your y-intercept, you can just do 2 and then cross over where you can. Alright, this one I'm coming on and just take a peek. I'm not check marking this one, but I do want to see what you have for it. Again, this is page 19 on the packet. The next page I'm going to have you go to. You are going to use decimals. You are going to try to find the x and the y intercept. The hint will be the following. If you get near the x-axis and the y-axis and tap on the graph itself, 2 dots will appear letting you know, okay, this one is going to be my x and this is going to be my y. The other thing, remember, like last time with your highlighter, you can't go to the negatives. You can't go to the negatives below. Put that highlight. So what page do I want you to go to? Please go to page 12. Please go to page 12. You'll type that guy right into decimals right after you. Right after you. Let's see if I get to my page 12.
Zoology. It's the word.
And their word officially is zoology. Let's see, page 12. So I want them to do the big one with the 1,000. Yes. Into decimals. Try and sketch that guy. Hint again with your highlighters. Please highlight the y-axis and the x-axis. Why are you highlighting that? Because this is going to be a real-world situation when you get to the actual assessment. And in the real world, you can't go back in time. Usually this bottom line is some type of time. It's months, it's days, it's something like that. You can't go beyond the zero. And in some of the early sketches I saw some people do, some people went back in time, but you can't do that. The height, you went to negative heights, you can't do that. So highlight this, and then when you go to decimals, make sure you only graph the portion that is in the good section, quadrant 1, you call it. The hard part, though, when you get that x and y intercepts, those will be a little bit tough. See, you can find it without me saying what to do. But once you put it in, it won't be as easy to see because they chose such large numbers. And I think on the assessment, they said that this is large. Let's go even larger. So they could have made the same point without doing it. So sketching the picture is going to be a little tricky. But I'm going to see what you produce. And then when we do it together, you'll be like, oh, that's what I should have done. All right, we went to decimals. This is page 19? Page 12? Page 12, page 12. Type in the formula over to the left. To get the y-intercept, you just click on the graph somewhere, and it will show those two. This one is good, the y-intercept, because of course he is positive. If you try to use an x-intercept, you are in trouble because of that -4. Your picture, again, you should highlight. Only that good stuff there. I'm going to come around and do a quick check mark, and then I'm going to take you to page number 3, for those who like to know what's coming up. Page number 3 is where we're headed next. I am going to stop recording, even though, remind me to start when I get back to page 3. Page 3. Some of this should be okay. Let's see what we got here.
Okay. I'm crazy. Tell me why. I relate.
All right. Grab a highlighter. We're going to do some highlighting. At some point, you're going to need to switch colors. So let's see what we got here. Am I recording? I am. All right. Step 1. Do me a favor. If you talk, hold off. Maybe step out. Come back later. Please put 2 pi under the 360. Put 2 pi under the 360. 2 pi is going to be what they want for a complete, I don't want to use the word. From beginning to end, it should normally finish in 2 pi. With a highlighter, please highlight. By the way, is it sine or cosine? Sine. 1, because they have it there, but 2, it begins here. Notice here the first hump of the sine always will end halfway between wherever the whole thing is going to end. In other words, this sine goes all the way to 2 pi. And I want you to highlight that. Don't go past the 2 pi. Don't follow the arrow. Just enough to know. This green says that we have 1 cycle. We have 1 cycle. 1 cycle just means what's the complete thing you have. And for now, you can close down the computers. You won't need those. You have 1 cycle in this length. Another word that they're going to talk about is periods. In this case here, a period is always going to be compared to 2 pi. In other words, you're going to have the number of cycles compared to 2 pi. So if they ask you, hey, could you please find the period in this problem? Your answer will be, I'm going to write a fraction. And what am I going to write on the top of the fraction? I'm always going to write 2 pi, because that's the official length that a sine and cosine should be in. The second part is how many cycles in the picture do you have? Like, how many of these complete sine waves do you have in 2 pi? Well, I only have one. Therefore, the period on this particular picture would wind up being 2 pi over 1. I have one cycle for this guy. The last question I'm going to ask you from time to time is for the frequency. The frequency is officially the reciprocal of, for example, if you flip the period, you have the frequency. If you flip the period, you have the frequency. Math way of saying that is the reciprocal. Again, when you get your assessment, if you don't fully get this section, you should still get to be okay. It won't be a computer section because of the way they're going to write the problem. So this one you kind of have to be able to do. So next one we're writing down is frequency. Frequency. Frequency just says how many cycles are there in a period. There is, if you flip it, there is one. There's one cycle in the period, or in the length, the full length. So we're doing it on the simple one. The next one, they're going to throw in a few extra cycles for you to put in the certain things. One last thing I need to write so that when they throw in a letter, for cycles, instead of writing the word, they chose the letter B to be the cycle. Nice. In other words, when they ask for the formula, they won't put 2 pi over cycles. They're going to put 2 pi over the letter B, which I probably should have done. Now it's going to add too much information. How do I want to fix this? Please write period over here equals 2 pi over B. Please write this over here. This is the math form. Write that down. Why is that going to be important? Because in the problem, they're going to refer to B. All right, let's see if we can do something with that equation up there so they know. Okay, so now that we know this cycle is how many of these we have, the period is 2 pi above how many of these we have. The frequency is get the middle answer and just flip it. With the equation, they're going to ask you some things. They're going to ask you for the amplitude, which is the number in front of sine. And they're going to ask you for the cycle, which is the number in front of either this symbol here, theta, or an x. So let me ask the question. I don't know where I'm running out of space to write it.
Can you just extend the
Will I lose what's up there? Let's see if I can figure it down where I don't. Oh, there it is. So write down amplitude. I'm going to write down this equation down here below so that it's closer. By the way, right now it's way too much information that I want in one grouping before I start having you look at something. But here we go. Can someone say what the amplitude will be in this problem? I heard it over here. Say it again over here. Yeah. It's 1 when you don't see a number in front of something. It's automatically a 1. Here comes the other question. I hate to ask this one. What is the number of cycles in this problem if I just had the equation? It's a number in front of theta. It's 1 again. 0 makes it disappear. But in this case, the cycle going to put the letter B because they're going to start referring to the cycle as B. All right, let's see if we can do this a few more times now in different cases so you get used to it. Oh, okay, I know what the cycle is. I know what the amplitude is. They're going to ask those three things: cycle, amplitude, frequency. They love asking those four. For someone who needs to see this with a little bit of red, let me put in some ones. So some people are like, where is he getting the one from? All right, let's take a go to the next page with some highlighters. I have to switch away, but yours is right next door to it, so hopefully you'll be able to refer to it. Here we go. First step in getting some of these things. For this first picture, we'll do together. The second one, I'm going to see if you can try to do it on your own. So here it comes. Highlighters. Please highlight the first cycle here in one color of a sine. Switch to a different color to show that there is a second sine wave. Whoever drew this, they did their best. They were nervous. No,
Was it you?
well, no, it wasn't
No?
me. It was another teacher named Karen, but she shares a lot of information. So, good job, Karen. Let me ask all together. How many? All right, and don't answer right away. Put it on your paper. Based on this picture and the highlighting, how many cycles are there? Don't say it out loud. I just want to have you write it first. How many cycles are there in this? I'm calling this period.
Time function.
Yeah, I guess I'll say in the sine function. Write it down. Write it down. This one I'm going to come around and I'm going to check your paper, and then we'll fill in some of these other pieces. The amplitude is not going to be a big deal. The period, once you know the cycle, won't be a big deal. If you know what the top of the fraction will be. So I'm going to come around and check mark. That's the first answer. Cycles. Somebody can do some of this other stuff. I know. So easy. Don't say the amplitude on this one. Oh, maybe it's not so easy. Amplitude? The height of the sine wave is the amplitude. That's 2.
Like 2.
Uh-huh. All right, and I probably should have done the. For those who are talking, hold. I should have probably done the period second. What's the top number on the fraction of the period? It's always the same.
It's
2 pi. And once you know your number of cycles, then you're able to put that down on the bottom. Well, that part we're going to have to try and figure out what they're doing on that second one, but I want to do a nice one, an easy one first, and then we'll figure out what's going on over there. All right.
Oh, it's the amplitude or like the big pictures?
Yeah, it's how high up it goes or how low it goes. Uh-huh.
I know it was 3 cycles. I don't know the amplitude. I didn't know the period.
Do me a favor, they didn't put in the word frequency. Please write in frequency and write that down. Once you know the frequency, you can automatically, once you know the period, you automatically know the frequency. Uh-huh. The frequency is a weird thing because it actually almost asks you the same question as the cycles. The frequency is that there are 3 cycles for every 2 pi.
So it's just period.
Yeah. The frequency is just that guy for the. Alright, so do me a favor, try to do these 4 items for the second one. With the highlighters, do the highlighter thing as well on that. That way when, hopefully the back of this page is enough, but this will be one of your 6. It won't be because some of it is, introduction, not one something done. Did we do anything that's prompt to the right on the front?
No, but we could.
Does that have an equation or it doesn't have an equation? At least I'm going to highlight with you.
I've seen that.
I love the Vogue.
People that look like celebrities.
Let's put in here frequency.
I look like you.
I mean, like, I thought I forgot to put trash, but I don't.
Oh, I can see that.
There are 4 of them. Let's do 4 tables. And so the 4th one is here. This table here, you guys will give me cycles. Let's see. Ashley's table give us amplitude. Back here, Max's table give us period, and right here they give us frequency. All right, here comes front table cycles, please. This table right up front here, right up front here.
Yes, I know.
All right, for now, put that away. 2, I'll take it from Jacob. Ashley's table. 2, we're going with the 2 right there as well. A period back there. Say it again.
Oh, wait, I retract.
Yes, Ashley retracted her statement.
Oh, thank you. I didn't even look at it. I just took it.
It's 3, sorry. I thought we were doing halves.
All right, yeah, it does go up to the 1, 2, and the amplitude
I didn't see
is 3. All right, back table period, please. Over the measurable 2, and then right here, frequency, please. 2 pi over 3. Yeah, so this one is true. It'll be just a flip of this one, and it may have check mark without maybe looking carefully. Now, yes, so when you get to a test, this 2 pi over 2, they are not going to write that 2 pi over 2. Does anyone, can anyone guess what they're going to write for 2 pi over 2?
Just pi.
They're just going to write pi, that is, 2 divided by 2 is 1, and 1 times anything is just that thing itself, so they're not going to put 2 pi over 2, they're just going to put pi. I didn't want to start throwing that part in right after this. Same thing here with the frequency. This one's a little tricky, though. They're not just going to put 2 over 2, 2 pi. This one is going to wind up as a 1. Let me write this one here. 1 over pi. I want you to take a look at that so you understand where that comes from. Right, so you're reducing this fraction here. 2 goes into the top, 2 goes into the bottom. Another way of saying it is this. If pi is the period, the reciprocal of pi, when you flip it, you wind up doing 1 over pi. I didn't want to get into all of that because that's about fractions. I don't know about fractions. When really the part I want is, can they find cycles? Can they find amplitude? Once they have cycles, can they find period, always 2 pi over whatever the cycle is? And can they find frequency by flipping? Those are the things I want you to have like nice and smooth. The last thing they're going to make you do now is they're going to start giving you equations. And you're going to have to pluck these things off and try to sketch something. That part I'm nervous about, but at least the straightforward part, I feel pretty good about it. So here we go. Let's see what the next things they have in line for us. This guy here. Yeah, let's see what we can do with this one. Let's see what happens with this guy. What page is this? This is 5, and let me see if I want to skip 5 and come back to him, if I want to go straight to him. All right, let's give it a shot. They give you the formula. Please write down those same torque items. Cycle, period, amplitude, and so again, cycle, period. No, it's cycle, amplitude, cap F, cap F, C-A-P, F, cap F, cycle, amplitude, amplitude, period, and frequency. Eventually, I'll probably just put the letters instead of writing out the words. And this is how math people get all the letters. they get tired of writing out all the words. So eventually, that CAPF will do the job. So let's see what they gave us. They gave us the A. You don't have to do anything with that. It turns out they gave us the B. The B, remember again, was cycle. I've been using the word because it's easier when it's time to produce this picture. But cycle, I'm sure they use C for cycle, but whatever. They gave us the cycle, so let's see what information we have, what we can put in so far. So there we go. Someone say out loud what the cycle is going to be. We got 2 for that. Someone different, what will the amplitude be? 1/2, that part straightforward. The period, fortunately, is always pi. 2 pi over something is going to be 2 pi over what? Over 2. Which kind of takes us back to the last thing that we just had a second ago. So this one I am going to write as just pi. Look at this. Now that you're getting older, stronger, just put pi on that one. And then frequency is 1 over pi. How many cycles will I have in the full length to see the entire picture? So period is just really how long do you need it to be to see the entire sine wave. Drawing it, though, is going to be, let's see if I can help you draw it. Let me take this guy down here, 1 over pi. Let's see if I can help you draw this. Because they are going to want you to be able to draw it, and we'll see how well you can do with that. So 1 over pi is the number of cycles I'm going to see in that amount of time that it needs to see the entire picture. Hey, Thomas, hey, how are you going to draw this thing? This is the complete thing we need for the cycle. They didn't put anything in. They didn't put a 2 pi. They didn't put whatever. How do you know what to put here? Well, the frequency is the thing that you need. Yeah, at the bottom of the frequency tells you what should be down here. Pi is where this is going to end. How tall is this thing going to be? Oh, the amplitude is going to tell me. You can just choose a mark and make that a 1/2. This is how you build it. So the frequency helps me know what to put at the very end. At least that's what I'm using this time. Even though it's the computer would tell me that, but I'll say the frequency. If it messes up on the next picture, that's fine. How do you draw a sine wave? Step 1, whatever the total thing is, cut it in half. The first hump, and you can close the computer, you don't need the computer right now. The first hump will take you to the halfway point, and the second dip will take you to the end. And so, if you know your amplitude, that's how high you're going to go. About halfway is when it hits the top of the hill. I hope so. I don't. Yeah. All right, now here goes. So the first hump on your sine wave goes to the halfway mark. The second hump goes to the end.
Yeah, if you would have
You know what? That's a good point too. That is good. All right. So I'm going to fix it in 2 ways. Here, by writing up to pi, it is true, we only showed half of the real picture. So the real picture really should go all the way to 2 pi. Here's what's going to happen if you have a pen. It's going to look a little bit ugly. If you have a pencil, we get to erase and fix some things. So I'm going to try and do it. Here we go. Let's see what happens. But again, this picture, if someone would offer this to me, I would say they know what they're doing. They know what, how much we need for a full cycle. Well, here it comes. I'm going to erase. All right, here we go. Here it comes. Let's imagine we're showing the whole thing, the 2 pi, like Marco was saying. If we cut this thing in half again, there's pi. You got two of them. If you cut it after, well, you got the first one, you got the second one. What you did before, they will probably have this new picture that I'm showing. Like how on the other one, they had more than one cycle. Oh, we had 2 cycles here. The other guy, oh, we had 3 cycles, wherever that other one that had 3 cycles. We're drawing one where you actually see all of them. What I drew initially was, what if, how much did I need just to get one of those cycles? That was the picture that I drew. I'm redrawing to show probably what it really should be, and I think Margot is right on this one. Alright, so here it comes. How do I draw that first sine wave that we need that goes in the first pi? You still cut things in half. It's always about, with sine, it's all about cutting it in half. And the first hump going to that halfway mark, and the second dip. Because we know there are 2 of these guys, there are 2 cycles. This picture should have that second part. Do it in blue, the second cycle. Cut it in half. Because with sine, the first hump always goes to the halfway mark. And the second dip goes beyond. Take a look at it, write it down. I think when I get to the test, I may have you just do one of the cycles. Alright, let me see what page comes next. I think they're getting the idea. Let me see which one comes next. Alright, once you answer a question, don't answer another one. Here it comes. What is the amplitude?
2.
Next person, let's see. I've seen this thing before. Someone tell me what the cycles will be. 3, because again, we know the cycles over that number below. What is the period?
Period is 2 pi over 2.
Yeah, which is a non-thing.
Wow, sound like 3.
And then what is the frequency?
3 over 2 pi.
There are 3 cycles in 2 pi. The question is, well, if they just gave us this pi thing and I wanted you to do the 2 pi, how do I split this up into 3 separate groups so I can have 3 separate pictures?
So like half.
It's going to be a little bit weird. I'm going to see if we should do this part. Alright, I'm going to try. It's probably going to be a bad idea, but here goes. If I were doing this, I would actually put in the 2 pi there. Be the whole thing. Then I would actually chop this line into 3 equal pieces, which is going to be a little bit hard to kind of guesstimate. Look at that. The first room, someone's living in there. The second room, someone's living in there. The third room, someone's living in there. And each of the room, a complete sine wave is living in that room. How do you draw a complete sine wave? I'm going to get an amplitude up here. 1, 2, 1, 2. How do I draw? And again, can you see if you weren't here, even if you watched this on the video, well, I'm probably not recording good. I'm recording. It's a little tricky. Here it comes. How do I get you into the first? And let's see. First room, I have to cut you in half. How does he know I have to cut it in half? Because when he draws a sine wave, he knows the first hump goes to that halfway mark, and the second dip
Okay.
goes there. Do me a favor as best you can. Please draw the sine wave that's in the middle room.
Yeah.
Cut it in half the middle room. And then, if you have the power, draw the sine wave that goes in the third room. But again, in each room, or in each segment of this 2 pi, up and down. For a test, I'm not sure if we get in trouble for not listing what each one of these points represent. Are you pi? Are you pi and a half? For my purposes, a student who has the skill to be able to decode this into this and produce this, I'll take it. Alright, I'm drawing the middle one. First hump, halfway mark. And then the third one, up to butt. First hump. Take a look at the pictures, see if you're confused where the three different colors come from. How does he know how high up and down to go? Amplitude. How does he know where the first sum ends? It's always halfway at the halfway mark. Room. And the sad part is the last one that we're going to kind of look at. Maybe this is another one. We actually blow some of the stuff out of the water. Add on. You can't just add on a 2 pi. If this whole thing were 2 pi, then technically that would be pi. And the picture for pi winds up being 1 whole scoop and a half. So someone wound up putting the 1 whole scoop and a half on the entire thing, which could be a little bit tricky to do, but it does mean the same thing. All right, let's try this last one that kind of messes everything up. But it's the version that they're going to attempt to use. But you know where you're trying to get to. Let's see. Not that one for this one. Not that one. That guy there. What page is this guy? 9? 10? 9?
Wow, that's sad.
I need a tiebreaker.
It's 9.
Go to page 9. All right. What is it? Cap F?
Yeah.
Please. They left out the cap. Please attempt to write in what these are. My only hint to you will be the B will have 2 pieces to it. Whatever comes in front of the X, known as just one number, or known as theta, is 1. Put those in. They didn't label pi or 2 pi, so that one we're going to get to choose what we're going to do once we try and figure out what this other thing is like. But your cap F is what I'm wondering about. Will they get their cap F? On the assessment, I think you'll get points for the cap F, and then the other half the point for the picture. So the picture part, so let's see what happens on cap F on this one. Be careful, some things are going to disappear. You can. Some things are going to disappear when you put this below 2 pi. But if you list it, write out your work, and I see what you did, I might do it. Well, you know what? I choose to give points. So again, in about a moment, this one thing I'm going to come and check mark to see what you have for your cap F. Some of it's going to be tricky. Some of it's wait it out. Wait it out, and then let me put it together.
Should we just start solving?
Almost, yeah. So I'm about to walk around to see what you guessed. Nonetheless, here we go. What is the cycle in this problem?
4 pi.
The 4 pi. Whoever's in front of X is the thing. Now we did all the easy ones first. You guys know by the time you get to these assessments, they don't like easy. They're like, no, we're not just going to replicate. We're going to do some weird, crazy stuff. The amplitude on this one is what? Here's the amplitude right here. The amplitude is always hiding in front of amplitude. It should just be the number in front, which is that hidden one. All right, so here we go. Period. Period is always 2 pi over the C, which I guess in this case could be. Take a look at that. See what that feels like. Yeah, we'll have reducing. Yeah, but don't let's not say that yet. Just so someone who, let's say they're not doing reducing. What is the frequency?
2.
But let's imagine we just had this.
4 pi over 2.
You know, because what I want is this. Let's say there's someone who's going to mess up because of all the changes. If I can see all these pieces in place, then I know you know. Oh, what do I do with the cycles? How do I turn it into a period? And how do I get the frequency? Now, yeah, it's true. In order to actually do the work, we will need to do the following. For the period, the pi's are going to cancel. and you just reduce the fraction, which is going to be 2 goes into 2 on the top 1 time, and 2 goes in the bottom 2 times. So the period is actually 1/2. Here comes the frequency. You just flip that, or just reduce the fraction again. The pi's cancel out. Anybody know what 4 divided by 2 is?
2. We didn't.
So this thing is kind of odd.
I think it looks good. We should continue.
There are going to be 2.
There's some.
There are going to be 2 cycles in this entire thing. Which, what's the entire thing? It's a 1/2. This whole one is weird. It's a weird thing. So here's what I would say. Hey Thomas, if I were sketching a picture, just so I can have something on my paper, I'm going to take the period, which is the 1/2, and I feel like something's up with my picture. I feel like there's something up with my picture. In any case, what I'm going to do is I'm going to mark that halfway mark. Picture that goes with this. Even though technically it should be, I mean, clearly there's going to be more for these. In any case, here's what I'm going to do. I'm going to put, what was the amplitude? Amplitude was a 1. And then I'm going to go first half.
Oh, what? Oh,
The second half.
I drew it like 4.
Yeah, and it should probably be that 4 and then some. Because 4 pi represents 4 times 3. So there should be like 12 of these guys stuck in between.
Oh,
Now,
never mind. Should I just do that?
we're not going to use this to say that one of them shows up in the halfway mark.
Oh, that makes it easier.
Yeah. So here's what I want you to think before I hand out